Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, what are we learning? We're learning how to find the angle measures of the angles of a right triangle by using trigonometric functions. How are we learning it? Through the finding angle measures using trigonometric properties notes and the finding angle measures using trigonometric properties assignment. When can we use this? To repair the roof of your house while making sure that the base of the roof is flush with the house and the slope of the roof allows for water runoff. How do we know we learned it? By getting a score of 4 on the finding angle measures using trigonometric properties assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the finding angle measures using trigonometric properties notes. Then I will give you time to complete the finding angle measures using trigonometric properties assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we will go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning with Irrational Numbers study guide and any incomplete assignments that you may have. Let's take a look now at the finding angle measures using trigonometric properties notes. Our notes begin with the learning goals and success criteria. Now, what are the parts of a right triangle? Well, if you notice, a right triangle has 3 sides, and this is our 90-degree angle. We call the side opposite of the 90-degree angle, or the longest side, we call that the hypotenuse. Then each of the other 2 sides we call our legs, and if we're looking at this angle here, this is considered the opposite angle. So notice it's the side that's opposite of where this angle is located. So if we drew an arrow from it, it would go straight to this side. So that's the opposite. And the side right next to it we call the adjacent side. So we have hypotenuse, we have opposite, and we have adjacent. Now, what are the trigonometric properties? The first one we call sine. And sine is the opposite side over the hypotenuse. So it's a ratio of the side lengths with the opposite side being on top and the hypotenuse length being on bottom. Now cosine is adjacent over hypotenuse. So we have our near side, and we'll take that length over the length of the hypotenuse. Now tangent is opposite over adjacent. So it's the length of the opposite side over the length of the adjacent side. The way we can remember this is SOHCAHTOA. So SOHCAHTOA is the easiest way to remember it. So is sine opposite over hypotenuse. Ka is cosine is equal to adjacent over hypotenuse. And TOA is tangent is equal to opposite over adjacent. Now, how do we use these trig properties? So let's say I wanted the sine of, we call this theta. So we want the sine of theta. So sine, remember, is SOH, cosine is CAH, and tangent is TOA. So we're going to take this and we're going to go opposite, which is 4, over the hypotenuse, which is 5. So the sine of theta is 4 over 5. Now we have the cosine. So the cosine is the adjacent over the hypotenuse. So the adjacent side is here. So this is 3 over 5. And tangent is opposite over adjacent. So the opposite is 4. And the adjacent is 3. So it would be 4 over 3. Now let's talk about inverse trigonometric properties. So inverse sine, this is what it looks like. So it's sine to the negative first power. So we call that the inverse sine. So if sine theta equals 1/2, then inverse sine of 1/2 equals theta. So it's just a way of flip-flopping it so we can solve for the angle measure using the ratio. So all we do is we change it to inverse sine and then we flip the theta and our ratio. Same thing with cosine. So we have inverse cosine. And if cosine theta equals 1/2, then inverse cosine of 1/2 equals theta. So again, change it to inverse and flip your theta and your ratio. And tangent's exactly the same thing. So we have inverse tangent, and again, tangent theta equals 1/2, then inverse tangent of 1/2 equals theta. So how does that help us find angle measures? So in this case, we want to find theta, which is this angle here, and we're given this side and this side. Well, this side is our adjacent, this side is our hypotenuse, so we have adjacent and hypotenuse, so we know that we're going to need to use cosine. So we'd say cosine of theta is equal to 3/4, adjacent over hypotenuse. Now, we can't solve for theta necessarily, so we need to go ahead and use our inverse cosine now. So we're going to change this to say inverse cosine of 3/4 is equal to theta. Now we can just plug this part into our calculator. So we're going to enter inverse cosine of 3/4 into our calculator. There's a link here that takes you to the calculator. And when we enter that in, we should see that it's 41.41 degrees. Let's look at another example. So this time, again, we're solving for theta, and we're given this side and this side, so we have our opposite and our hypotenuse. So we know that opposite and hypotenuse should be sine, so we should end up with sine theta is equal to 3/4. Now, this isn't going to help us. We need to get theta by itself, so we're going to use the inverse sine. So this becomes inverse sine of 3/4 is equal to theta. So we will plug in inverse sine of 3/4 into our calculator, and when we do that, we get 48.59 degrees. One more example. We have theta here, and we have that this side is 3 and this side is 4. So now we're going to go ahead and solve for theta. Now we have our opposite and we have an adjacent side, so we know that in order to do this we need to use tangent then. So it will be tangent theta is equal to 3/4. Now we can't use tangent here because that's not going to help us with theta, so we're going to need to use inverse tangent. So this will be inverse tangent of 3/4 is equal to theta. Now we can go ahead and plug that into our calculator. So we put in inverse tangent of 3/4 into the calculator, and when we do that, we should get 36.87 degrees. There's a video here that shows you how you can check angle measures in calculator.net. So you can watch this video and see how you can check your work using calculator.net. Let's talk now about how to check our work when trying to find an angle measure of a right triangle. So in this case, let's assume we're given two side lengths and we're expected to find an angle measure. So let's say in this triangle we know that C is 6 and we know that B is 4. And let's say that we're trying to find angle alpha in this case, this angle here. Well, we put it into the calculator, B is 4 and C is 6, and we hit calculate. And notice it's going to tell us everything else we need to know. So we can see that A in this case would be 4.47214, or 2 square root of 5, which is fine. That's not what we were looking for. What we were looking for was angle alpha. Well, we can see that angle alpha is 48.19 degrees. Angle beta, if that's the one we were trying to find, was 41.81 degrees. And we know that angle C here, this angle here, would be 90 degrees because it's a right triangle. So we can check and find any other missing information using this right triangle calculator.
Let's take a look now at the finding angle measures using trigonometric properties assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. The first one says, which of the following trigonometric properties would be best to find the angle measure for angle A? So we have angle A here, and that's the one we're trying to find. And the sides we have are the adjacent side and the hypotenuse. Well, which trig property uses adjacent and hypotenuse? Well, that's cosine, so we would use the cosine to find angle A. We'll answer a couple of those. It says, what is the angle measure for angle A in the figure below? So we know that this is 2 and this is 5. So we have the opposite side and the hypotenuse, so we need sine. So sine of theta is equal to 2 over 5. And when we flip that around, we end up with inverse sine of 2 over 5 is equal to theta. And when we put that into our calculator, we should see that the answer is 23.58 degrees. So we'll go ahead and mark that as our answer. And we'll continue to answer these questions all the way until we get to the end of the assignment. Once we get to the end of the assignment, we'll go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.